shots, and he did all his shots. Yes, we lost to us.
Mr. Maynard?
Yes.
Somebody's at the door.
Thank you.
That's a good point.
So, I've got,
This game at 4. This game at 4. Here.
probably did slow.
You'll never have as much style as that man.
Little beaver? I'm already beating him, nigga. His name is Little Beaver.
Tell me.
Where's the next one?
Is it possible? Can we just,
There's somebody at the door.
H is fine. But then, like, Monday, last day of March. Tomorrow's April 1st. No fools. And let's see. And tomorrow is a school day. Yes, Okay. So it's about to be April, and after April, of course, is May, and May is AP exams. Yes. So just a reminder, and I will keep reminding you guys until you get sick of me hearing you. Yeah. Anyway, remember your AP exams are all online this year. Okay. So that means that you need your DCPS laptop in order to make that happen, and you need the Blue Book app up and running for all of those. If you're a junior and you took the SAT last Wednesday, you should be set to go. Just make sure that you keep updating your computer as necessary, which means that you need to be using your computer on a semi-regular basis, making sure that it's connected to the internet, like here at school, and making sure that we push those updates through, making sure that the clock is working and says the right time, because Blue Book won't work if your clock is off, okay? So for my sophomores in here, you guys need to make sure that you are using your DCPS laptops, that they are up to date, and that Blue Book is active and working for your testing, okay? So just make sure that you are taking care of your DCPS laptops properly in preparation for AP exams, which are in about 5 weeks. Yeah, 5 weeks, y'all. Our AP exam, remember, is at the end of the 2-week span, so that's like Friday, May 16th. So we have a bit more time for ours, but hopefully you don't get burnt out before you take it. But
Dana's here.
that's okay.
No. It's just all together. No.
I don't know. The College Board,
Oh, I put that there. That's our mascot.
schedule. So
It's your mascot.
know or
Mascot.
care about any other things.
Mascot.
May is just
My grades are better than yours.
Hi, Dana.
Graduation is May 28th.
I like your hair.
Wednesday.
I know, it's kind of.
Yes.
What?
I got him the same day gonna work.
Yeah, hell.
Yeah. Great question.
I mean, entire quarter? We have it's like the 5th day. How do you miss it? Bro,
Okay, so the question was, if you did not hear Elijah, how does taking 2 AP exams on the same day work? So naturally, there's a morning and there's an afternoon. Typically, you would want to be in the testing room at 8 o'clock for a morning exam. And basically, so it really comes down to time. Hopefully, you will be done with your AP morning exam to where you can scarf a quick lunch and jump right into your afternoon exam, which the doors should open at 12. So now there is a certain window that we have to start an exam by, as in, like, we have to start as in, you have to open up the packets, but now we don't have packets because it's all online. I don't know how it works. But basically, we have to officially start like by 9 a.m. for a morning exam, okay? And for the afternoon exam, we have to start by 1 p.m. So we have that 12 to 1 where we'll, say the necessary things, and at some time in that range, you guys will officially start and you're good to go, okay? So the testing coordinator, Ms. Swierzik, she will be aware of the students that are taking multiple exams in the same day, and she's keeping track on times and stuff. So if she needs to push off the afternoon exam for a little bit in order to get you guys done, allow you to scarf something real quick and then jump into your next exam, then she'll make that happen. In the not so strange case, but definitely not happen often, where a morning exam just goes too long, and you miss your afternoon exam, there is an alternate AP exam that you may take later on. That happens usually after the official 2 weeks, and then there's the alternate testing. The IB students tend to take a lot of AP alternates because, well, there's no IB alternate exams. You either take it on that day or you don't take it at all. So the IB exams kind of take precedence, and then you can take an alternate AP exam on a certain day. So, but we're gonna try our best to get you to test both the same day, allowing a short break to eat some lunch.
Don't you have to pay for like alternate exams so you can use it?
If it's your fault that you miss it, yes, you have to pay for the alternate exam. Yeah, but if it's not your fault, obviously you don't. Good question. Any other questions on AP, IB testing, exam schedules? You are getting here in the near future a piece of paper showing all of your exams and when and what days and times they are, okay? If you wanted a sneak peek, you can check out the AP and IB exam list on the News You Can Use board. It's been up all year, but we're getting closer to, so it's, you might care more now. Yes?
I did the shots.
Okay. It happens to me too. Okay. Any other questions for the good of the order? Tyler, or are we okay? Okay. Cool. All right, so I think that's it for announcements. There's no seniors in here, so whatever I had to say to them is moot. So we are, so we've got a center of mass lesson today. This is the official last lesson that feeds into the AP exam. We still have a circuits chapter that will start here on Wednesday, and that'll be our last chapter worth of stuff. After that, we'll do review mode and end of year projects for the rest of the time. So, super fun stuff coming right up. Yeah. All right, so you just got handed your brand new AP Physics 1 equation sheet. So as we are heading towards the AP exam, and as we do practice problems and sample exams and all of that fun FRQ stuff, we are going to be referencing this instead of the IB equation packet that we've been using all year, okay? I may, in the near future, spend some actual time just going through these equations and kind of comparing, like, into the equations that we learned before. Sometimes they look a little different so that we can know exactly what's on the equation sheet. But you may find, because I talked about it last class, the extra fluids equations are on here, as well as the center of mass equations that we'll talk about are on here as well. And our first one actually comes right at the top of the left column. It's going to be that fourth one down. I have it copied on our board here as well. So we talked briefly about finding the center of mass of an actual object when we did our car derby project, and basically wherever you find that the car balanced, that was where the center of mass was. But you could do it in all directions. So like you could do it along like the X direction, you could do it along the Y direction, and the Z direction if you wanted to. If we had a three-dimensional object, then that's what it would be. So this particular equation is designed more for, let's say we've got a multiple masses, okay? And we're calling the group of masses our system. We want to find out what is the center of mass of the system, okay? So we've seen the sigma before here, that just means sum. So we're going to take each mass, we're going to multiply it times its position, and we're going to add all of those terms together, kind of like what we did back in collisions when we had a conservation of momentum equation, where we did the mass times the velocity of the object 1 plus the mass times the velocity of object 2. So it's kind of like that. In fact, next year I'll stick this with the collisions momentum chapter because it fits better, and frankly I forgot that this was a thing, so that's why we're doing it now. And better late than never, right? There you go. Yes, Caleb. Oh, no, I did forget. You reminded me. Thank you. Our dad joke for today. I apologize. I have to eat my breakfast without toast because I'm lactose intolerant.
Corny ass joke,
Alright,
bro.
go for it.
Oh my god, you're actually laughing at the game too. That shit's funny.
Good question.
You see this thing with this big ass water bottle? You gotta be back on.
Yes, testing. Because you guys are the best. Yeah.
What do you say?
All my sophomores.
Ma'am.
Sorry. Come here, man.
No, never mind. Wait, is this?
That's not for that. That's just for the best Friday.
Yeah, I know. Is this Mr. Smith's class? I don't want to test in his class.
I got into it for please,
Damn
bro.
it.
God, the school hot. Please, the school hot. If I get this,
It's right next to Mr. Smith's class.
I literally text somebody.
Oh, really?
I'm a real boy. I text Mr. Morgan, so I just go to first word.
does anyone know which room Miss Gula is?
No, I do not.
I'm praying
And
to.
204. Is she in the English building?
She's close to this other thing.
Is she on the second floor?
Yeah.
Oh. One scoop a day keeps the evil away.
Keep in mind, he was done an hour like after you.
Shut the fuck up.
Hey man, it says it on the song, man.
This nigga got 36 points only dribbling the ball one time. He got 36 points dribbling the ball one time.
Okay. All right.
More impressive than this.
All right, guys. Let's get back to work. So, I'm really just gonna kind of lead you through some examples. Lesson is a little on the shorter side for today, but that's okay. And then we'll move on. Your pods for today are a little different. It's actually so I made up a worksheet. So I posted that worksheet in the pods for today. So that's pods A211 in Focus. So feel free to jump into that whenever you go into your pods. But the quiz is already up as well. So pods and quiz both in Focus. You don't necessarily need to do the pods digitally. You can still just do it on paper and either show it to me, or you can upload it into Focus like you usually do. Okay. Okay. So let's take a quick look here. So let's say that we have just a one-dimensional system of masses here. And let's say here's our coordinate system: 1, 2, 3, 4, 5 in the negative, 1, 2, 3, 4, 5 in the positive. Okay, and let's just throw up some masses here. So let's say this is going to be a 2 kg at the -1 position. I want let's see. Give me a 5 kg right there at the +3. And I'm gonna say 4 kg right there at the -3. All right, so we got 3 masses. These are gonna be point masses all along the X line here. So I want to know, where is the center of mass? I would like you guys to guess. Where do you think the center of mass is going to be? I will take 3 guesses from different groups here. Okay? And the group that gets the closest gets an extra team point. Go.
-1/2? No, negative half.
-1.
-1/2.
-1/2.
Yeah.
So like right there.
No.
I don't know.
What the fuck?
You wanna take it?
I
right.
don't think that's
Elijah.
right. Wait.
At 0. Okay. Right in the middle. All right. So you're purple. All right. One more.
I thought it
Go.
would be half. One.
And so a +1/2.
Think about it. It's 5 on that side.
All right.
6 on that side.
So you're orange.
Actually, maybe it is half.
Yes?
Maybe it's not -1. -1/2. It's half.
You want a +1?
I say half. Half makes sense.
We already have
Yeah, I
one.
know. Yeah, half. You know why I said -1/2?
No.
It's because I thought
In
the
between the
middle was
orange
0.
and the purple?
I didn't consider that there was like the middle could be different.
So that's a positive quarter.
Cause I think it's 0 for you. I think it's 0 for
Okay. Alright. Well,
Fuck.
My bad.
let's see who's right. Let's see who's right. So we get to use our new equation here. Alright?
You can just look it up. Not look it up.
So what we're gonna do is we're gonna take each mass and we're gonna multiply by its position. Remember, direction matters because it's a vector. All right. And so we're just gonna work down our line. We'll start off with our 4. So this is gonna be our mass of 4 times the position is at a -3. That sign matters. Okay. And again, we're just gonna add up all of our terms. So m times x times, and then another m times x. So this is our 2. Our 2 is at a position of -1. All right, so that's m times x. And then plus our third term, our big 5. Our 5 is at a position of a positive 3. Okay, so that's how we're gonna fill out our top. The bottom part is just the sum of all of our masses. We're not multiplying it times anything, and that's really just the total mass of the system. Okay, so that's really just 4 plus 2 plus 5. Okay, well now we're gonna calculate. Let's see what we got here. All right, so we got a negative 12 minus 2 plus a 15 gives me a positive 1. Okay, a positive 1 divided by, let's see, that's 11. Ooh, so 1 divided by 11, that gives me 0.09. That's a positive though, so that's where we are. So 0.09, that's going to be really, really close to 0. Let's see, this was 0.25, but the purple would have been closer, so.
Okay, see, but y'all were laughing at me like I was crazy, bro.
All right, very good, very good. So Spice Girls picking up a point for them.
Symbols aren't really.
Good job,
Bro, I
guys.
was thinking like half a point.
But
You write down at the top.
you guys were all close though. You guys were all close. So if you were to guess, that's not a bad job. It's not a bad job. Okay. Naturally though, the heavier the object, the more the center of mass is going to skew towards that one. Okay.
I'll know what the symbols are.
All right, Spice Girls picking up a point. Good job. Okay. Now, although this only says X, we could also use this in the Y direction or in the Z direction. Okay. So let's do an example where we've got a two-dimensional grid where we've got masses in the XY plane. All right. So here we go. All right, so here we've got, let's make it interesting. So naturally, this is the positive X direction, positive Y, negative X, and negative Y. And all of those are just ones. Okay, so let's start off with a 5 kg right there. That's going to be at 1-3. Okay. Then we're going to do, let's see, 2 right there. Okay. So that's a -2 for the X, +1 for my Y. And let's do,
I know, but like, I'm so confused in the last page. I have no idea what he put down.
Here's a 4, right there, boom. At a +3 and then +2. All right, same game. Where's the center of mass? Where do you think it is?
0 to that 1 pair.
So I think it's
Negative 1, 1.
negative. He literally said that.
Mr. Maynard, can I go up there and, oh.
Yeah, yeah. If you guys just want to come up and mark it, go for it.
If you want to say that, you can. I'm just
I'll
saying.
take 3 or 4 curves. Come on. It doesn't matter, just pick one.
Yeah, I thought it was where Elisha was going, I was kind of close, but I wanted to be like a little bit over. Yeah. A little bit more. I can't see. Go up. Yeah, right there. You can right there. What? No! Why are you so far?
Okay, but you still got the 4. You still got the 4.
Oh,
You still got the 4.
Do over a little bit like Sia. The other way, like Sia. Do a little bit like Sia.
Here, use an orange.
Okay.
Go to the left like Sia.
Okay, but you still have the 4.
Yeah, but it's a good angle.
5,
What?
4,
Like here?
Yes!
3, 2,
I
1.
swear to God, you're close to me.
Okay, all right. So
Let
you
him
guys
say he's
are all
close
kind
and
of
I
in
swear to
the
God,
same
I'm
range.
just
All right. Well, let's find out. Now, in this case, we have an x-coordinate and a y-coordinate. So I have to use this equation twice, one for the x's and one for the y's. So let's get started. All right, so for the x's, so let's start with our 2. So the mass is 2 times the x position is a -2. Okay. The 5, let's just go left to right here. So the 5, the mass is 5 times its x position, that's a +1. Okay. And then the 4 mass, 4 kgs, times its x position of a +3. All right, and then on the bottom again is just the combined mass. So the 2 plus the 5 plus the 4 gives me 11 on the bottom. And let's see, on the top we've got -4 plus 5 plus 12. So that's definitely not what I, no, hold on. Plus 12 gives me 13, so 13 over 11 gives me 1.2. +1.2, okay. So far, it looks like orange is the closest in terms of the x direction.
I'm gonna
All
kill
right,
his
let's
ass.
check out those y's.
I'm gonna kill his
Let's
ass.
check out those y's.
I'm gonna kill his ass. You close.
All right, we've got the y center of mass. Again, same deal. I'm gonna take the mass and I'm gonna multiply times the y coordinate or the y position divided by the total mass here. All right, so once again, start off with the 2. So 2 times the y position is a +1. Okay, that was easy. The 5 times its y position, that's a -3. Okay, and then the 4 mass times its y position of a +2. And it's all still going to be under 2 plus 5 plus 4, so 11. And let's see what we have here. So we got 2, looks like -15 plus 8 gives me a -5. -5 over 11. So that's going to be -0.45. All right. So, wow. Looks like orange is right on. Yep. Because we've got to have a +1.2, so a little further than a +1 on the x. And then we are going, so technically it should be right above that orange, but orange is definitely the closest one.
He literally put
Yes.
it one place above mine. He put it.
Yes. Good job, Quantum.
He put it one.
Did you get the right
Yeah,
No.
no.
Sorry.
We just figured it out.
All right, good job, guys, good job. So, finding the center of mass based on multiple masses within a system, we got to use our equation, or if it's an actual object, we're just going to find out where it balances. Whenever that object moves, though, because now we're going into the velocity of the center of mass, okay? So let's take like a hammer or like an axe. Axe throwing is big right now, and I've gone at least once, maybe twice, I think. I'm not that good at it, but that's okay. So when you throw the axe is going to spin, right? And it's naturally going to spin about its center of mass. But the center of mass isn't necessarily going to be in the middle of the handle. If you were to measure the length of my handle, the center of mass isn't going to be there. It's going to be more shifted towards the head, because the head typically is the metal part of the hatchet, and it's going to weigh more than the handle. So we think it would spin about this, but actually it's going to spin about the center of mass. As in, as I throw this thing, the center of mass is going to follow whatever path we typically would associate like if I were to throw a ball at that particular speed and angle, the center of mass is going to follow that same curve. If you watch the video, they have some really cool things that showcase that. But it's going to spin naturally about the center of mass as it flies through the air, which kind of goes back into the rotational inertia aspect of things, because spinning about the center of mass is going to give it its smallest, the smallest moment of inertia. And if it's going to do whatever's easiest, it's going to stick with the smallest moment of inertia. Okay? So as you throw it, the center of mass is what we track in terms of those paths. Okay? All right, so our next equation, our velocity of the center of masses is actually the last one at the bottom of that left-hand column, and it looks kind of the same as our position of the center of mass. Let's take a look. Let's take a look. This one actually connects a lot with collisions, okay? So we've got the velocity of the center of mass, which we just talked about, as it's going to follow typical, as if this were just one normal object. The center of mass is going to follow that same line of action. So, but in terms of calculating, if we had different objects in our system like we've been doing for the past couple of examples, it's going to be the sum of each of the masses times its own velocity. And we add them all up and divided by, again, the same combined mass at the bottom. Okay? Now, although the mass times the position really doesn't mean anything, does mass times velocity mean something in physics? Yeah, what is it? Momentum. Yes, momentum. So that's why there's an extra part to that equation, and it actually means, okay, well, this is really the sum of the momentum of the objects divided by the total mass of the objects. If we were to multiply this over, we have the total mass of the system times the center of mass velocity is equal to the change, not change, but the sum of the momentum of the parts. Okay, so this really ties into when we talked about collisions, and the key part for collisions is also, so as we have our two objects, okay, and as they're going towards each other, or maybe it's like a rear end type of thing, whichever kind of collision we have, the velocity of the center of mass is going to stay the same before and after the collision. So we can use this kind of approach as well for collisions too. For example, let's say that we have a rocket, okay? So this rocket, it's going straight up, so, and there's going to be two parts to this rocket. There's the capsule where the people are in, and then there's the big fuel tank part that is going to split off from the capsule, okay? So imagine the rocket is going up at a certain speed, the rocket fuel has been spent, it's time to disengage, and as it's going, there's the explosion or the release of the fuel tank, and so the capsule gets shot up even faster. The real question is, what happens to the fuel tank? Does it continue to go up? If so, how fast? Or does it get shot down? If so, how fast? So that's going to be our question that we're going to answer using this new equation. So here we go. So here's our rocket. So here's our fuel tank. Let's say our fuel tank, at the moment where it's empty, right before it splits off, okay? Right before it splits off, this is like 1,000 kgs. Most likely, if we're talking about like NASA or X rockets, these are going to be like millions of kgs. Like these these things are huge. So, but just to keep the numbers somewhat nice, let's just keep it 1,000, okay? So this is, I mean, it's still going to be a big, if we were to make this rocket here at Paxson, it would still be, you know, significantly big, like the size of a car or something, okay? All right, so here's our fuel part, and then here's our capsule. Let's say our capsule is 200 kgs. Okay, so about 1/5 of the fuel tank part. All right, and right before separation, it's going up at a speed of 50 meters per second. Okay, so this is before the collision, or the explosion, or the detachment. Okay, and then once it separates, so now my capsule is now going, now it's going faster. It's now going at a speed of 80 meters per second, okay? I wanna know what's happening to the fuel tank. What is the final velocity of our fuel tank? And we're gonna use our new equation to answer that question. Does it continue to go up? If so, with what speed? Or does it go down at what speed as well? Okay, now we can also apply this to 2- and 3-dimensional explosions as well. We're not going to go that way. We're just going to stick to our 1D for now, okay? All right, so first up, let's talk about, let's do our velocity of the center of mass is equal to, so I've got 2 pieces here, and I'm going to multiply, or each mass times each velocity, okay? We're going to assume that up is positive, so that's a positive 80, and that's a positive 50. All right, so the capsule mass is gonna be 200 times its velocity, 80 meters per second. Okay, so that's my first term. I'm gonna add my second term, the fuel part of it, so that's gonna be 1,000 times, well, V, because we don't know what V is, that's what we're trying to solve for, okay? And then divided by, it says the total mass of the object, so that's going to be the 200 plus the 1,000. All right, now we're trying to solve for V, okay? But we don't know what the velocity of the center of mass is, or do we? Because it's the same before and after the collision. And if we look at the before side, since the objects are stuck together, the center of mass has a speed of 50. That is the velocity of the center of mass. So our VCM is actually 50. So 50 is equal to, let's see, that's going to be 16,123 plus 1,000 V plus 1,200 on the bottom. Okay, and now we're just going to solve for V. We're going to do our algebra math stuff. I'm actually going to divide by 100 on both the top and the bottom to kind of make it a little nicer here. So that means that 2 zeros from each of those terms goes away. I'm not going to do it to this side because I did canceling top to bottom, okay? So I can do that. So let's see what happens. Our numbers should be a little nicer. 160 plus 10V divided by 12, all right, yeah. And then we're just gonna do the math here. So let's see, 50 times 12, that's what, 600? Is that right? Yeah, here we go, still got it, boom. All right, so 600, 160 plus 10V, subtract that over, that's what, 440? 440, watch my math, because sometimes I can, you know, mess things up inside my head, but I'm pretty sure that's right. And then divide both sides by 10, so my velocity of the fuel tank after it separates is going to be 44 meters per second. Is that positive or negative?
Positive.
It's definitely positive, yeah. So it continues going up, but slower than it was going before. So from the capsule's perspective, the capsule is now going faster than it was, and the fuel tank, it almost seems like it's going away from it because the capsule's now going further faster, and the fuel tank is now going slower. But that would be a good example problem of our velocity of center of mass for accommodation of objects as it pertains to a collision. Now, one more thing. Although it doesn't show it in the equation sheet, if we have an equation for the position of the center of mass and the velocity of the center of mass, what's the next logical step here? Position, velocity, acceleration. Yeah, there we go, there we go. So let's just see, because we don't have to do it, but let's just see what it would look like using this same form. So the acceleration of the center of mass, if we were to have a multiple, object system here. So the acceleration of the center of mass, what would it look like? It would be the addition of each mass times its acceleration divided by the total mass. Hey, what's mass times acceleration? Force. Yeah. Yeah. So wait a minute. So that means that this top part is the sum of all of the forces acting on the system of the mass over the total mass of the objects. This is really another version of Newton's second law, but applied to a system of objects, not just one object. So, cool stuff. Again, not in our equation sheet. You might not even come up against problems using it, but that is the next logical step in our conversation. All right. Any questions for the good of the order? All right. Feel free to take 5, and then once that's over, then we're going to jump into those pods. Remember, the pods are the worksheet that is embedded inside the focus pods. Okay. And again, you can still do your work on paper. If you're able to finish before the end of class, you get that extra point, as always. And of course, there's the quiz as well. Remember, our quiz from last time on fluids is open until midnight tonight. So if you haven't done so yet, make sure to do so before it closes out.
Oh, can you do that class notes?
Yes, I can check class notes if you took some. Yeah.
I don't enjoy a lot of physics lessons, Brian.
Oh, good. I enjoy most physics labs. Yeah. All right, thank you. Right.
Oh, no.
Yo, Francis. Oh, what happened? What am I about to do? Like in the next 2 minutes? Or like what are we about to do like next class?
You felt like the next 2 minutes.
I mean, I've got a whole list of things that I want to do, but if you have a question about something, I can
It's
assist.
about the last one.
I just wanted to make sure this thing got
I deserve that team.